Hello students! Welcome to another fun of learning. Welcome to our quarter 4 science lesson, and I'm your grade 10 science teacher, Mrs. Mary Joy Esca. Our lesson for today is about conservation of mass in chemical reaction. Chemical reaction is a process in which one or more substances, the reactants, are converted to one or more different substances, the product. A chemical reaction rearranges the constituent atoms of the reaction to create different substances as products. The substances that go into a chemical reaction are called the reactants, and the substances produced at the end of reactions are known as products. For example, when sodium reacts to chlorine, it forms sodium chloride or the industrial salt. The sodium and the chlorine are the reactants, while the sodium chloride is the products. The reactants and the products in chemical reaction can be written into chemical equation. Those are the symbols used in writing chemical equations. Plus sign separate two reactants or two products. Next is arrow yields and separate reactants from products. And the reversal arrow, it is used in the place of arrow for reversal reaction. And when we see the S after the element, it designates solids, L for liquid, and G for gaseous state, placed after the formula. And AQ designates an aqueous solution. The substance is dissolved in water, placed after the formula. And when we see delta at the top of the arrow, it indicates that heat is supplied to the reaction. While if we see PT at the top of the arrow, a formula written above or below the yields sign indicates that it is used as catalyst. In this example, we have the platinum element. During the chemical reaction, the mass of the reactant is equal to the mass of the product. This means that the atom rearranged, but they are not created nor destroyed. And this idea can be explained with the law of conservation of mass. What is the law of conservation of mass? The law of conservation of mass dates from Anton Lavoisier in 1789. Discovery the mass is neither created nor destroyed in chemical reaction. And the mass of any one element at the beginning of a reaction will equal to the mass of that element at the end of reaction. A balanced equation conforms to the law of conservation of mass. Let us check with our previous example if the number of atoms of each kind on the left side of the reaction is equal to the number of atoms of each kind on the right side of the equation. We have steps to consider on how to balance chemical equation. The first is write the chemical equation of the given chemical reaction. So in the word equation of sodium reacts chlorine to produce sodium chloride, we have that chemical equation of this. Second step is to make a list of elements on each side under the equation for both reactants and products. In this example, we have both sides, the sodium and the chloride elements. Third step is to identify the number of atoms of each element. On the reactant side, the number of atoms of sodium is 1 and the chlorine is 2. On the product side, the number of atoms of sodium is 1 and the chlorine is 1. So, they are not equal. The last step is find the lowest possible coefficient to balance each atom. To make the equation equal, we put coefficient. For sodium atom on the left side, there is 1 atom of sodium multiplied by coefficient 2, written before the symbol of sodium, which is Na. Coefficient is always placed before the chemical formula. For chlorine atom, there are 2 atoms of chlorine on the left side. On the right side, there is one atom of chlorine that is multiplied by coefficient of 2 found on the left side of the compound. This is the balanced chemical equation for this reaction. Always remember that coefficient is always placed before the chemical formula. To have a clear picture of the chemical equation, the number of atoms is multiplied by the coefficient written before the chemical formula to make the equation balance. Let's have more examples on how to balance chemical equation. All the time, our bodies are carrying out through processes, storing the energy that we take in as food and expending that energy. A chemical reaction changes one set of chemicals into another. A series of chemical reactions turns the food we eat into energy that can be used by our cell. Other series of reactions spend that energy by building cells, growing, and exercising. 6 chemical elements make up 99% of the human body: oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. Those elements form the key types of molecules in the body: carbohydrates, lipid, nucleic acid, and protein. And those molecules form all our cells and carry out most of the chemical processes needed for life. Before I end with my lesson, I want to leave a perfect quote for you students from Thomas Fuller. All things are difficult before they are easy.